Hello, Mr. Aaron, Mr. Ryan, are you right? Okay?
Yeah.
Okay, good. Okay, so I think we have talked about this problem like maybe 300 days ago. Okay, so we are given an array of integer. Let's just put it simple. We have a array of 100 numbers. Okay, 100 numbers. So index from 0, 0 to 99. Okay, this is 99 index, and 1, 2, okay, etc. So you can imagine there are 100 buckets, and each bucket contains a number. Then we want to support two operations. One operation is called query. The other operation is called update. Just two simple methods. The query will take two parameters, the left, the right. And the update will take two parameters, the index and the value. Okay, so let me explain. Query, the left and the right specify the range inclusive. Okay, so let's say all the buckets contain the number 1. Okay, so there are 100 number 1 initially. Okay, so let's say we want to query the left will be 0, right will be 99. So we want to query from this range. This is the left to this. So basically this is just asking the sum of all the numbers between this range. So what's the answer? If initially all the numbers
100.
Well done, okay. And how about 0 to 5? Just give me the sum of
5.
the 5. 0 to 6, yes, 6 numbers, yeah, okay. So, okay, very good. So query, this is a method which takes two parameters, the left index and the right index, inclusive. And we want to return the sum of all the numbers inside the range. The update, very straightforward. We want to update the value at index I. For example, if we say update 0 to 100, then this value needs to change to 100. Make sense?
Yeah.
How can we brute force? Just simple. How can we brute force?
Check every possibility.
The query, how do we do it? Very simple, right?
That's even a problem.
That's not even a problem. Brute force is a problem. Query, very easy. Return sum. I'm not going to write the code, okay? I'm just going to explain. Return sum if this is an array, okay?
But that wasn't even my question and my statement. But what was even the problem?
So we given this data structure. So we given a mutable. What's mutable?
Changeable.
Changeable. Yeah. We given an array which we will mutate it. We will change the values, and we want to support these two operations: one query, one update. So the brute force way to update, very simple, right? We just change the value in by the location. Then let's O1, right? We can change the values of the array as much as we can, right? This is O1. Query, simple, because we are given a range. We can just do a loop, just get the numbers and sum it up, right? Yeah, this is brute force, yeah? You understand, right? This is very simple. Okay, so let me write this table as a comparison. So let's query, let's update. Brute force, okay? Query, what's the time complexity? We're just looping, taking the numbers, adding them together. What's the time complexity?
N.
O(n), right? Because we need to just imagine this left will be the left boundary, R will be the right boundary. And then there's only one way. You have to take each number, add it up together. So that's O(n). Update, O(1), right? We talk about that, right? Because if you want to change a number, we just go to the index and change it. This is elementary school, right? Or primary school. Very simple. It's straightforward, intuitive. Is there any other way?
There is, and
Yeah?
and anyway, I don't really understand the problem. Like what you're doing, just playing around with query and update for fun.
We want to implement. We don't support these two. Yeah. Okay. So these are the two tasks. We want to design it. So given the brute force, we are not doing any optimization. Given this array, given the left, given the right, and then we can do it, right? Query, basically this is called sum the range, right? Sum the range. Then we can just find the range, add the numbers together, O(n). Update the number, O(1), okay? there's another way we have talked about prefix sum. Do you remember prefix sum? What's prefix sum?
The prefix of the sum
I heard that before.
is the
like,
part before the thing that comes after the sum.
Prefix sum. Okay, so
Oh, wait.
how? Yeah, you want?
so like, let's say you're doing 1 plus 1 plus 1.
Yeah.
And first you do 1 plus 1, the first two, and then you get 2. And then when you go into a third digit, instead of doing 1 plus 1 plus 1, you just do 2 plus 1.
Yeah, that's part of it. Okay, but how is that going to play in this query? Very good. Yeah, that's part of it. Okay, so let's say we want to get the range of from here to here, right? Yeah, we want to get the sum of this part. Prefix sum. Then I have another array which is called prefix sum. So each number stores the sum of all the numbers up to it. Okay, so if this is, remember this thing 1, 2, 3, 4. Okay, these 4 numbers. The prefix sum will be 1, 3, 6, 10, right? The number adding up to it. Why is that useful? I want to compute the sum of this range, 2 plus 3, right? So 2 plus 3 equals 5, right?
Yeah.
Previously, we just add numbers together, but now we don't do that. We get this. This is prefix 6. What does 6 mean? 6 means all the numbers up to this point, which is 6, right? And then 1. All the numbers up to this point is 1. The sum of all the numbers inside the range equals 6 minus 1. Make sense?
Yeah.
Okay, so that's very useful, right? So let me just expand this list. Okay, put in more numbers here. Okay, so the sum is prefix sum. Okay, what's the sum of these? We don't add the numbers together. What's the sum? 3 plus 4 plus 5 plus 6. What's the sum? You should be able to do it in
18.
one. How is that 18? How do you get 18?
3 plus 6 plus 4 plus 5.
No, you are doing the calculation, adding it up together. That's Bruteforce. But here, prefix sum, we want to get this number, 21. Minus 3. So 18. Yeah, got it? Because 3 is all the numbers here. The 21 is all the numbers. So you subtract, you got the sum here, right? Got it? Make sense?
Yeah.
Oh, you get it, right? Okay, so this is called prefix sum. So to query will be O1, right? Yeah, because we're getting this number once. Getting this number once, we do the subtraction. Okay, O1. How about the update? If I said, here, instead of 3, I want to change it to 100. So what values needs to be changed? What values needs to be changed? If I change the number 3 to 100, the prefix sum, what value needs to be changed? Is it all the numbers from this side to the end, right? Yeah? Because I have updated this. I have incremented this number. So all the numbers from this point to the right needs to be updated, right? Yeah? So that's O-N. Yeah, well done, well. Okay. So look, slightly different, right? This is O1, O1, O1. This is O1, O1. Okay? Yeah? We also talk about another method, which is called square root decomposition. So, okay, let me quickly explain this idea. So, the idea is that we decompose, for example, there are 100 numbers, right? The square root of 100 equals
10.
10. Okay, so there are 100 numbers. Let's break it into 10 box, big box. Okay, 10 box. Each one is square root of the size. Okay. So square root of n, meaning that each box responsible for all the numbers of square root of n. So basically, the first box contains the sum of the first 10 numbers. The second box contains the sum of the second 10th. Okay, from 11 to 20. Okay. So how is that useful? I want to compute the sum. Bless you. I want to compute the sum from 1. Okay, let's say I want to compute the sum of all the numbers. Then we just add these 10 boxes together, right? I want to compute the sum from 5 to 25. Okay, so 25 is here, right? 5 is in the first box. 25 is in the third box. So we just have to add this part. We know this the sum of this box, right? This contains 10 numbers, the sum of 10 numbers. And then we need to add the partial sum of these and these. Just imagine 10 box. We have 100 numbers, right? We have 100 numbers. But now we have a 10 bigger box. Each box stores the sum of the 10 numbers, right? So if I want to sum the range from 5 to 25, then this range cross 3 boxes, okay? The first and the third box are incomplete, but the second box, it covers the second entire 10 numbers in the second box. So we can just look it up this number, right? Imagine there could be a few complete boxes in between. Then we just add these numbers instead. So this will be another way to speed up. And to update, also, we just have to find, the number of boxes is intersects, and then we update the box. Okay. So that's called square root decomposition. So the times complexity is square root of n square root of n. This is what we have talked about before. Now today I want to talk about, the binary tree, right? What's binary tree?
A tree with
What's the binary tree? A
some
data structure, right?
some circles and lines with numbers.
Nodes and leaves, right? Nodes and leaves. Okay. Can we use this binary tree to solve this problem? I give you a hint. The root. Okay, this is today's topic. The root, the leaf. What are the leaf nodes in the binary tree? Those one without any kids. Okay, binary tree. A child, a parent can have only at most 2 kids. Okay, let's say this is root, right? The parent, the node which has no parents is called the root. Okay, and these are descendants. Okay, so here, let's say this is the root. Okay, let's say each node I have left, right, and sum. Each node I store 3 things. So on the root node, I will store. Look, you'll be amazed how pretty this is. The root node, I will store the index 0 from 0 to 99, and the sum of all the numbers from 0 to 99. Okay? Yeah. Okay. On the left, on this node, right? This node, what's the middle of 0 from 0 to 99? Half 50 or 49. Okay, it doesn't matter. Okay. Here I will store all the sum from 0 to 49 or 50. Doesn't matter. Okay, another sum. And here
49.5.
I will store from 50 to 99 and another sum.
No, 49.5.
So you see, and every time,
49.5.
Okay, so each node I have a range, right? I have a range. I specify the range. And I get a sum. And then the left, I cut it in the middle, right? It's just like binary search, yeah? The left here will be 0 to, what's the middle of from 0 to 49?
I think it's 49.5.
No, yeah, but index, there's no half index, right? So it could be, you could choose 49 or 50 depending how you want to run the index. Right? It doesn't matter. 0 to, let's say, 24, okay? Yeah? And then here will be 25 to 49, right? Inclusive. Okay? And then when this goes on, until the leaf node, each leaf node, the left index and the right index will be the same, right? So let's say the left from 1 index to the index 1. So basically the range contains only 1 number, and this number will be, the sum will be array 1, okay? How is that useful? So just imagine we have given this kind of tree, a binary tree, where the node of each binary tree is a range, left to right, and the sum. Okay? And the leaf node, just imagine, can you imagine? Right? This is your imagination. The leaf node, how many leaf nodes? Okay, one question, how many leaf nodes?
6.
No. Given from 0 to 100, 0 to 99, how many leaf nodes? I was just saying.
99.
100, 99 minus 0 plus 1, okay? Why? Because I was just saying each leaf node will be a single range. Left index equals the right index, and the sum, we know it. And once we have it, we can merge it up. We can do this. Yeah, we can do this bottom up. Okay? Then we can build a tree this way. Okay? recursion. I'm not going to write the code. It's going to take a while, but you now understand this idea. Why is that useful? Let's say to query, I want to compute the sum from 0 to 25. So should I go left or right?
Left.
Left. 0 to 25. Should I go left or right?
Left.
Yeah, etc. This is very simple, but this is simplified. How about if I want to calculate from the range from 45 to 55?
Right, left,
Remember, we need to check the middle, right? 45 to 55.
left, right.
Look, 45 to 55 will be here, right? But here, this node covers, right? So look, this 45 to 55 will be in both sides, all right? So how do we do it?
Both.
Yeah, we need to go left and go right to find the range, right? To narrow down the range. Am I right? Yes? Okay, so 45 to 55, then we need to go to the left, which is 45 to 49, and then 50 to 55.
No, it's not there. Isn't it up from like
Oh, yeah. Okay, yeah, you're right. Yeah, here. So let's say 45 to 55, okay? So now the root node will be 0 to 99, but this is not what we want. The middle will be 49, right? Yeah? But look, 45 to 55, it has this, we need the sum in both sides, right? So we can split it into two. On the left will be 45 to 49. On the right will be 50 to 55, right? And this, we can trace this down to the leaf node. Am I right? Does it make sense? Mm-hmm. How about update? If I want to update the value, let's say 49. I want to, no, let's choose a different number. 45. Okay, so 45. Every time we check it in the middle, right? It's on the left side, right? We move here, right? And then here, 45. 45 is on the right, right? Yeah? And then goes up, yes, because look here, this is 0 to, this is 24, right? The middle, we check the middle. It's like binary search, right? We go to the leaf node. Once we go to the leaf node, we update the value, and we need to update the sum, right? We update, for example, we change this value here. Then the sum will be also changed because the leaf node is only one single node sum, right? Then we change the sum, and we also change the sum. Then we need to update the sum here. And once we have sum here, we also have sum here. We need to update the sum here, and this goes up. Make sense? Yeah? What's the time complexity if you think of this way? I'm not going to implement again because it's too much work. But this is a very excellent idea. Segment tree. Okay? So segment tree is binary tree. Why is it so special? Because each binary tree node contains a range and a sum. So if you want to query from 0 to 99, then if it matches the node, then we immediately know the sum, right? If not, then we need to trace, just like a binary search tree. If it's on the left, we go to the left. If it's on the right, goes to the right. If it covers, the range spans into both sides, then we need to get the partial sum from the left tree and the right tree, and we add it up together, right? Yeah? So the time complexity, this is our segment tree, right? ST. The query, what's the time complexity? What's the time complexity to search a number in a binary search tree? Every time we split into half, we have binary search.
Log n.
Okay. How many times maximum? Let's say I have number from 0 to 100. Right? Every time you guess half, right? This is binary search. How many times followed by this strategy you can guess it? I have a number from 0 to 100. Okay?
I know, 8.
8, yeah. How do you get 8? Why? 8 or 7, right? How? Why do you get this number 8 or 7? Yeah. 0 to 100. Why is it? Every time you cut in half. So basically it's the same thing, right? 2 times 2 times 2 times. How many times of 2 will be exceeding 100? 4, 8, 16, 32, 64, 128, right? 1, 2, 3, 4, 5, 6, 7. Okay? 7 times. Exponential this way. Log this way, right? Yeah? we talk about this, right? 2 to the power of 3 equals A, right? Log base 2 A equals 3. 2 to the power of 3 equals A, log. This is log, okay? To update, to query log n, to update. What's the time complexity to update? I want to change the number in this tree. I need to trace it to the leaf node. And once I update the leaf node, I need to go back. What's the time complexity? Come on, it's there. What's the time complexity?
It's just like you haven't been listening. Oh, log n.
Yes.
Same thing.
Same thing, boy.
It's not, okay. Okay, I'm not going to write
Can't
the
you just
code.
say replace it to log n log n?
Okay, so which one is the best?
The last one. O log n.
Which one is smaller? Square root of n and log n. Which one is smaller?
Log n.
Log n is smaller, right? We can plug in the values, right? Okay, square root of 100 is 10. Square log n. Log 100, 7, right? 7 is less than 10, right? Yeah, and that's how you
Why
compare.
7?
But this complexity is just... Yeah.
2 to the power of 7
Yeah.
is
Is the bigger than 100, cross the 100, right? 2 to the power of 6 is 64. 2 to the power of 7 is 128, alright? Okay, so this time complexity is describe the growth of the complexity when the problem size increase, okay? One last question, do you understand this? Or am I talking rubbish? Do you understand this?
yeah.
What do you think about it?
Yeah, it's okay.
It's okay. Is it useful?
Yeah, okay.
Okay, that's it for today. Bye bye.
Bye.
Bye bye. Bye bye.